This is the review for our final. I will be working on it. This will be a rather long video, but at least you'll get your problems for your final worked out. So, number 1 says draw a picture of each of the following. Adjacent angles are two angles that share the same side. So if this is one really big angle, angles 1 and 2 are adjacent. They actually share this middle ray. Vertical angles are formed by two intersecting lines. So 1 and 2 are vertical, and then 3 and 4 are vertical. So those are vertical, and then these are vertical. Supplementary angles are two angles that add up to be 180. So let's do 120 and 60. They do not necessarily have to touch, but they can. Complementary angles add to be 90. So let's do 40. And 50. Write each angle measure. These are vertical angles, so this one would be 75 degrees. This one would be 180 minus 75, which is 105 degrees. And since it's vertical, this one down here is also 105 degrees. Remember that converse is flip-flop. So we're going to take everything after this if and flip it with everything after this then. So it becomes if they are adjacent supplementary angles, then angles are a linear pair, or the angles. Inverse is not. So if angles are not a linear pair, then they are not adjacent supplementary angles. I feel like there should also be the contrapositive on here. I don't think this printed right. Let me see. Ooh, it didn't. Okay. Well, here, let me put in a blank page. Okay. So, after inverse is contrapositive. So that is if, and remember this is flip-flop, not. So if they are not adjacent supplementary angles, then they're not, then the angles are not a linear pair. And then the biconditional, it uses if and only if. So, it would be the angles are a linear pair, or angles are a linear pair. If and only if they are adjacent supplementary angles. And hold on a second. Okay, so those are all of the conditional statements, and then it says write an example for the a counterexample for the statement below. If you attend Humble High School, then you're taking geometry for a math class. All that you need to write is this still has to be true, so you still have to attend Humble High School, but it has to be a math class besides geometry that Humble offers. So we have to prove the second part false while the first part is still true. So it still has to be a math class that we have here at Humble, so it couldn't be like trig or something like that because we don't teach trig here. But you could list any other math class that you know that we offer at Humble. So Algebra 1, Algebra 2, Statistics, AQR, Algebra 3, College Algebra. All those things could be an example. I'll just put Algebra 2. Because that's the next class all of you will be taking. Write equation of the line parallel to the one shown in the graph. So we need to count, this is 1, -2, so there actually should be a line right here, it just didn't print on this program. So we count how many, it's rise over run for our slope. So it's going 1, 2, 3, 4, and 1, 2 to the right. Remember, if I drew my little guy on here, he would be walking uphill, so it's positive. So rise, we rose up 4, and we ran 2. So that means my slope is 2. So the equation of the line parallel to this, remember parallel has the same slope. So we just write an equation that has a slope of 2. And you could add or subtract anything onto the end, or you could just leave it as this. It could be +5, it could be -4, whatever. The back end doesn't matter. The thing that matters is this right here. Find the midpoint of this segment. Just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're going to count over half of 13 is 6.5. So 1, 2, 3, 4, 5, 6.5. So it would be right here. That point is 1/2 because we're going to go over a half x and up 1, 2, 3, 4, 5. A half 5 is the point. Is the midpoint for that. Find the perpendicular bisector to the segment containing these endpoints. And I know that you guys have a lot more paper down here to use. So the first thing you're going to have to find is your slope. And your slope is y2 minus y1 over x2 minus x1. So it is 5, let's do 7 minus 5 over -2 minus 2, which is 2 over -4, which reduces to -1/2. So then the second thing we have to do is find our perpendicular slope. So our negative becomes a positive, and then we flip it. So 1 over 2 becomes 2 over 1. So that's what perpendicular slope is. You change the sign and you flip it. So positive 2 over 1 becomes just a 2. Then the third thing we have to do is find our midpoint. So that's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So we're going to have negative 2 plus 2 divided by 2, and 7 plus 5 divided by 2, which gives us 0 over 2 and 12 over 2. And that means that our midpoint is 0, 6. So now we're going to use all this information to finally find our perpendicular bisector. Using the equation, the fourth thing is plug it into the equation. Y minus y1 equals mx minus x1. This is our m, this is our x1, this is our y1. So it will be y minus 6 equals 2x, sorry, this is x minus 0. So y minus 6 equals 2x. Add 6 to both sides. Y is equal to 2x plus 6. That is your answer for number 7. Hopefully all that fit on your page. You should have had enough room. I just didn't for mine. Okay. Find the length of the diagonal of each unit on the grid is 1.4 inches. So this is 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1.4. This is 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1.4. Which, if I bring up my little calculator, 8 times 1.4 is 11.2. So this is 11.2, this is 11.2. So now we do Pythagorean theorem. A squared plus b squared equals c squared. 11.2 squared plus 11.2 squared equals c squared. And 0.2 squared plus 11.2 squared is 250.88 equals c squared. Take the square root of all of that. Oops. $15.84 is your answer. List each angle measure for the figure below. This angle measure would be 54 degrees. The top would be 180 minus 54 minus 54, which gives me 72. Because it is an isosceles triangle, given those two bottom angles are congruent. Okay, write an equation of the line perpendicular to the line below. So we've got to find our slope. They're missing a couple of lines out of here. I think there should be that many. Let me check it in just a minute. So we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that's right. Let me check the original just to make sure. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. The printer just doesn't like this program I'm using. And then it goes over 1, 2, 3, 4, 5. And if I drew a guy and he was going from left to right, he would be going downhill. So it's rise over run, and he is going downhill, so it will be negative. So negative rise, I rose up 10, and then I ran 5, which is negative 10 divided by 5 is 2. So a line that is perpendicular, we got to find our perpendicular slope. This negative becomes positive, and this is really 2 over 1, so we're going to flip it to 1 over 2. So my perpendicular slope is a positive 1/2. So my equation just needs to have this. Anything else you write is perfectly acceptable. It's not going to be wrong, but this is what's important. This is the part that has to be there. You could do -5 to complete it. It's whatever. What is the slope of a line parallel to NO? Well, it would help if it had printed whatever NO was. Oh wow, it missed a lot. Okay, so NO, we go up 1, 2, 3, 4, 5. We went up 5. And we're going to run 1, 2, 3, 4. And lastly, if I drew a little guy, no, I can't actually draw him, but if I drew a little guy and he was walking from left to right, he would be walking downhill. So downhill is negative. So a slope of a line that is parallel would be y equals -5 over 4x. And remember, this is the important part. And we could do like plus 10. Okay, list all the corresponding angles for the figure above. Remember, corresponding is the same side skip thing. Sorry, I need to get to my highlighter, and currently I couldn't. Okay, so 1 and 3 are corresponding, and then change colors. 2 and 4 are corresponding. 5 and 7 are corresponding, and then 6 and 8 are corresponding. So those are all of my corresponding pairs. So it is 1 and 3, 2 and 4, 5 and 7, and then 6 and 8 are all my corresponding pairs. Okay. List the alternate interior angles. So alternate interior 2 and 7 and 3 and 6 are inside and across from each other. So that is 2 and 7 and then 3 and 6. Sorry I'm jumping around so much. This program is not letting me control my colors and things. List the same side exterior angles for the figure above. So same side exterior. So they're on the same side but on the outside. So 1, did it say same side exterior? Okay. So 1 and 4 and then 5 and 8 are same side exterior. 1 and 4 and 5 and 8. Each pair of linear pairs. This is going to be a very, very long list. Because a lot of them overlap. So 1 and 2 are a linear pair. 2 and 6 are a linear pair. 6 and 5 are a linear pair. And then 5 and 1 are a linear pair. So that's all of the ones from up here. They're any of the ones that draw a straight line. So 1 and 2, 2 and 6, 6 and 5, And then 5 and 1 are all of my linear pairs. They all make a straight line. So, because with all those linear pairs, we have 1 and 2, 2 and 6, 6 and 5, and 1 and 5. And then on the bottom, we have 3 and 4, 4 and 8, 8 and 7, and then 7 and 3. So 3 and 4, 4 and 8, 8 and 7, and then 3 and 7. List the new vertices after it shifts 3 units down and 4 units right. So we have V, W, and X. 3 units down and 4 units right. 1, 2, 3. 1, 2, 3, 4. W is at 1, 1. 1, 2, 3. 1, 2, 3, 4. X is at 1, 2, 3, 4, 5, 6, 7. 7, negative 2. And since I can't see V, I'm going to do it the algebraic way. V is at negative 5, negative 2. So if it moves down 3, negative 5 minus 3 is negative 8. And right 5, negative 2 plus 4 would be 2. Yours on your paper, you should actually see it, so you should be able to move it. Rotate it 90 degrees about the origin. So Q, R, S, T, the originals. 1, 1, 2, 3, 4, 5, 6. Negative 9, 9. Negative 3, 3. Negative 1, 7. So 90 degrees about the origin. It doesn't say which direction, but usually that means clockwise, so it should end up here. So you need to turn your paper, take your top and put it to the left, so that this is actually the top. And if you do that, you can plot your new points. So for R, we're going to go left 9 and up 9. So this is my new R. For S, we go left 3 and up 3. This is my new S. And then left 1 and up 7. And this is my new T. So my new triangle, R prime is at 9, 9. S prime is at 3, 3. And T prime is at 7, 1. Okay, in order to do sequences, you have to list the original points. So A is at 2, 3, 4, 1. B is at 5, 4. And C is at 6, 1. So now my X's will stay the same, but my Y's will turn negative. So this will stay 4, this will stay 5, this will stay 6, but I'm going to change the sign of all of my Y's. So negative 1, negative 4, negative 1. And then I have to plot those. 2, 3, 4, negative 1. A prime. B prime. And C prime. And then for the next one, I'm going to take these new ones and subtract 4 from my x and add 3 to my y. So a double prime, 4 minus 4 is 0. Negative 1 plus 3 is 2. B double prime, subtract 4 from 5, which is 1. And then add 3 to negative 4, which is negative 1. And C double prime, subtract 4 from 6, which is 2. And then add 3 to negative 1, which is 2. So it should be at 0, 2. That's A double prime. And at 1, negative 1, B double prime. And at 2, 2 is C double prime. What are the new vertices of a triangle below after being reflected across the x-axis? Let's see what that really looks like. Okay, so if I'm flipping these over the x-axis, I just pasted this here. J, K, and L. All the primes. So if it's reflecting across the x-axis, you just see how far it is away from the x-axis. This went up 1 from the x-axis, so to make J prime, we go down 1. This went up 1, 2, 3, so we're going to go down 1, 2, 3 for K prime. And this one went down 1, 2, 3, so we're going to go up 1, 2, 3 for L prime. So J prime is at negative 1, 2, 3, 4, negative 5, negative 1. K prime is at 1, 2, 3, negative 1, 2, 3. And L prime is at 1, 1, 2, 3. State the information below in coordinate notation. So S originally was at negative 2, 1, and S prime is at negative 2, negative 1. T is at 0, 5, and T prime is at 0, negative 5. And U is at 3, 1. U prime is at 3, negative 1. So all that changed is that my x's are the exact same, but my y's changed signs. To check if these could be a triangle, you add the two smaller sides of the triangle, and they should be greater than the largest. So is 9 plus 8 greater than 20? That's 17. It is not greater than 20, so this does not produce a triangle. Does 3 plus 4, is that bigger than 5? 7 is greater than 5, so this, yes, does produce a triangle. I don't know why these keep coming off, so we're going to see if we can paste a new one. Okay, it says, given the following information, which can be used to prove triangle congruence, and all it says that angle D is congruent to angle C, angle O is congruent to angle A, and angle G is congruent to angle T. Well, that's angle, 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 and that does not prove congruence. So given that information, you cannot prove congruence. Then it says if GIH is 43.2 degrees in the right triangle below, what is the measure of GHI? What is this? So get out your calculator. And it's 180 minus 90 minus 43.2. 46.8. And given this following information, does this prove triangle congruence, and if so, by which method? A is congruent to U, C, R, is congruent to BS, and R is congruent to S. So that is angle, angle, side. Given that angle A is congruent to angle F and AN is congruent to FL, which one can you use for angle, side, angle? Angle, side, we would need this angle. Angle, side, we would need this angle. So we would need to know that angle N is congruent to angle L. State the postulate used to prove triangle congruence for the figure below. This is side. We know it's a 90-degree angle, and they share this side. So side, angle, side. Side, angle, side. Side, angle, side. Name each point of concurrency. These are perpendicular bisectors because they are at a 90-degree angle and they are bisected. So this is the circumcenter. These are altitudes because they are only 90-degree angles, so this is orthocenter. These are medians. They are the midpoint to vertex, so this is centroid. And these are angle bisectors, so this is incenter. Name each construction below. This one is an angle bisector. This is the altitude of a triangle. This one is a parallel line. And this one is perpendicular, bisector, midpoint, all of those things. And that's the end.